We are in Trentino, in the north of Italy. What you see is the ECT STAR, the European Centre for Theoretical Studies in Nuclear Physics and Related Areas of the Bruno Kessler Foundation in Trento. The ECT STAR is located in the beautiful 350 years old Villa Tambosi. ECT STARS plays the role of a so-called transnational access center within the HadronPhysics project of the 7th Framework Programme of the European Commission. We are here with Professor Achim Richter, who is presently heading this international center. Professor Richter, would you please perhaps briefly introduce yourself to the audience?
I'm a trained nuclear physicist and have been working in a variety of fields, nuclear structure, nuclear reactions, hadron physics, symmetries, accelerator physics, and quantum chaos. I'm a professor at of experimental nuclear physics at the Technical University of Darmstadt in Germany and have been directing the ECT STAR since November 2008.
Can you tell us what is the role of this institution in the European nuclear physics community?
ECT STAR is a member of the Nuclear Physics European Collaboration Committee, NUPEC, and it is concerned with fundamental research. It has been founded in 1993 and with about 700 visiting scientists per year from all over the world, spending from a week to several months at the center, ECT STAR has achieved high visibility and a coordinating function in the European and international scientific community. The goals of the research center are to arrange in-depth research on topical problems at the forefront of developments in nuclear and hadron physics, to foster interdisciplinary contacts between nuclear and hadron physics and neighboring fields such as particle physics, astrophysics, and condensed matter physics, to encourage talented young physicists by arranging for them to participate in the activities of the ECT STAR by organizing training projects and establishing networks of young researchers, and most importantly, to strengthen the interaction between theoretical and experimental studies.
What role does the ECT STAR play as a transnational access center for European research?
The importance of ECT STAR for European research lies in its mission. It creates the necessary conditions for excellence and state-of-the-art research in hadron physics by foreign collaborations and bringing together specialists from all over Europe and the rest of the world. It offers, furthermore, to the European research teams a natural forum for holding workshops and collaboration meetings to discuss results and tackle problems and exchange ideas. It promotes coordination of European research efforts, preventing isolation of smaller research groups, particularly in the less favorable regions of the community, strengthening the mobility of the European researchers and putting them in a strong worldwide competitive environment.
Besides running workshop, collaboration meetings and doctoral training program, is there any other activity?
Yes, indeed, ECT STAR has a very lively in-house research group consisting presently of 10 junior and senior postdoc researchers from all over Europe.
What do they work on?
For answering this question, let us have a brief look at the nucleus. It is a very small object composed of neutrons and protons. These particles are called hadrons, but they are not elementary, since they are composed themselves of so-called quarks. The quarks are held together and are confined inside the hadrons by the strong nuclear force, which is mediated yet by another particle, the gluon. From the theoretical point of view, all of this is described by a unique and self-contained theory called quantum chromodynamics, or QCD in short. From the experimental point of view, these structures are probed by means of electron, proton and ion beams in nuclear physics experiments at accelerator facilities. So research done at ECT STAR is thus concentrated on one hand with theoretical explanations of the phenomena observed, and on the other hand with the development of new tools and models capable of predicting new experiments. Accordingly, the research topics investigated at ECT STAR range from low-energy nuclear theory, effective nuclear field theories, quantum chromodynamics, up to new states of nuclear matter, the so-called quark-gluon plasma.
In which way would you see ECT STAR as a transnational access activity contributing to the benefit of the society?
Since 1993, some 11,000 researchers from 50 different countries, about two-thirds coming from the European member states, have visited the center, experiencing intensive training and exchange of ideas. The society as a whole has clearly benefited both from the advancement in basic science as well as the development of the collaboration on a global scale.
As a final question, why do you think should young people choose to study science, and why should they do it in Europe?
In short, science trains the curious mind to ask the correct questions and provides the tools to look for answers. This is far from easy, but very rewarding. As an example, consider questions about the origin and the evolution of the universe. Answers to these questions are very much linked to nuclear and hadronic physics, that is, to basic science. And Europe, with its many theoretical and experimental facilities, is simply ideal for studying this subject.